This video is on the law of cosines. The law of cosines works for all triangles. It could be a right triangle, an acute triangle, or an obtuse triangle. And here are the three law of cosines. So if you have this triangle where you have angle A, angle B, angle C, capital A, capital B, capital C, and then you have the uh, side length A, opposite angle A, side length B, opposite angle B, side length C, opposite angle C. Then these are the law of cosines. So this says that the length of one side squared will equal the length of the other side squared plus the other side squared minus 2 times the other two sides length times cosine of the angle that matches this over here. Okay, now how do we know this is true? Like, where did they come up with this law of cosine? There are several different ways to prove the law of cosines. I'm going to do it using the Pythagorean theorem. So for this video, I'm going to prove this one right here. Okay, so here is that same exact triangle. All I did is I drew this vertical line to indicate the height. And so this vertical line will cut side B into kind of two sides. I'm going to call this the green side here on the right. All right. So now that we have this height drawn in, there is now this right triangle here on the right side. Now, because that is a right triangle, I can use sort of right triangle trigonometry. And in right triangle trigonometry, sine of an angle will be equal to the length of the opposite side divided by the length of the hypotenuse. So here, let's have the angle BC. So if we're doing sine of this angle C here, that will equal the opposite side, which is our height, divided by the hypotenuse, which is A. So that's what I've written here. Sine of C, sine of angle C is equal to the length of the height, which is in red, divided by the side length A, which is our hypotenuse. Okay, so I'm going to solve for the height. So if I want the height by itself, to get rid of this divided by A over here, I'm going to multiply both sides times A. So height divided A times A just becomes height. And then sine of C times A is just sine of C times A. Okay, so right there I've solved for height using sine. We're going to do a similar thing in order to find the length of this green side. So let's use cosine to do that. Once again, I'm talking about the right triangle here on the right. All right, so here I'm trying to solve for this green length. So I'm going to use cosine, and with a right triangle, cosine of an angle will equal the adjacent side, or the side that is next to the angle, divided by the hypotenuse. So cosine of angle C is equal to the adjacent side, which is this green part, divided by the hypotenuse, which is A. So cosine of C equals that green part divided by A. Solve for the green part by multiplying both sides by A, so you get this. So this green part is equal to A times cosine C. This red part here is equal to A times sine of C. All right. Now let's label that red and green side in our picture. There we go. So now if the length from here to here is equal to B, and then this length over here in green is equal to A times cosine B, in order to get this part right here, that length right there is equal to the long one minus that short one. So this length right here is equal to B minus A times cosine C. And I've just written that. I labeled that in our drawing here. So that's B minus A times cosine C for this length right there. All right. So at this point, we're now going to start looking at the triangle on the right side. So we're going to look at this right triangle over here. Okay, so once again, that is a right triangle. So I can use things that work with the right triangle. And here I'm going to use the Pythagorean theorem. And you might be used to it read as a squared plus b squared equals c squared. Since we are already using a's, b's, and c's here in our picture, I'm not going to use those letters. I'm just going to say it's the height squared plus the base squared equals hypotenuse squared, which is words that describe that a squared plus b squared equals c squared. So here's our Pythagorean theorem with just slightly different words. Okay, so our height is right here, which is equal to A times C, A times sine of C. So height is equal to A times sine of C. Our base is down here, which is equal to B minus A times cosine C. So I'm going to change my base there to A minus B minus A times cosine C. And finally, our hypotenuse is C. So I'm just going to change the word hypotenuse to this C. Okay. So now that I have this formula right here, which describes the left-right triangle, let's simplify this. So I just copied that equation right here. I changed that middle part to purple so it's easier to see the different parts. Now, let's simplify this by doing some algebra. So A times sine of C squared is just A times sine of C multiply a times sine of c. I did the same thing with the other ones. You have b minus a times cosine c squared, which just means it's that same thing multiplied twice. And c squared is obviously c times c. So I just separated all of the squares into two multiplies. Okay, so a times sine of c times a times sine of c. So that's just four things multiplied together, which means that's the same as a times c times sine of c times sine of c. So a times a is a squared. Sine of c times sine of c is just sine of c squared, which is written like this. So this right here is sine of c times sine of c. All right. Let's skip this purple part for right now, and let's do the easy part at the end. C times c is c squared. Okay, so that's how I went from this line to this line. Now let's simplify that purple stuff in the middle, which takes a little bit more math, but if you have this times that, a minus b minus a times cosine c multiplied b minus a times cosine c, that ends up giving you this. B times RB just gives you this right here, this b squared. So that's our first terms multiplied together. B multiplied by the second term, negative a times cosine c, gets you, and then if you multiply those two, that gets you the same as this one multiplied by this one right there. So that will end up becoming this when you put them together. And finally, our negative a times cosine c multiplied negative a times cosine c gets you our final term here. So that's just multiplying two binomials. All right, that's probably our most complicated math right there. Now, so that's how I went from this line to this line. I just multiplied the two binomials. Okay, now at this point, looking here, this is one term, another term, third term, fourth term, fifth term. Okay, since these terms we can just move around in whatever order we would like, I'm going to move this term right here. I'm going to move that in front of our b squared. So I'm just going to pick up this term and move it in front of our b squared. So that's how I went from this line to this line. Okay, so why did I do that exactly? Because I see for these two terms right here, they both have an a squared. So I'm going to factor out an a squared. So if you factor an a squared out of this, I'm sorry, wrong line. If I factor an a squared out of this term right here, I'll get sine squared c. If I factor an a squared out of that term, I would get a cosine squared c. if me saying it that way doesn't make sense, you can always think of it as a squared multiply this one, gets you this term. A squared multiplied that one, gets you this term. So that's how I went from this line to this line. I factored out an a squared. And why did I do that exactly? Because our sine squared plus cosine squared of c, using our Pythagorean identities, sine squared plus cosine squared is equal to 1. So this whole thing right there just becomes this. And then a squared times 1 is just a squared. And the only difference between this line and this line is I just I put the c squared on the left instead of having the c squared on the right. So that right there is equal to c squared. So c squared is equal to that. And I just switched that so it would exactly look like our original equations at the very top. But there you go. This right here is the law of cosine. So once again, one of our sides squared is equal to another one of our side lengths squared plus the other side length squared minus 2 times our 2 side lengths times cosine of this angle, or the corresponding angle to that. All right, there you go. So this is one way you can prove that the law of sines works. That was this one right here. Here are other 2 law of cosines. You can find those other 2 law of cosines doing the exact same procedure. All you do is take our picture and rotate it. So if I rotate it like this, and then do the exact same procedures, first draw your height, etc., that would end up getting this one, I believe. And if I rotate it some more and did the same thing, first draw my height and then do the same sort of procedure, I would get this one. There are other ways also to prove law of cosines. All right.